with acid-base reactions. So in acid-base reactions, what do we always produce? If you remember from last lesson, Lochni?
Water and
Lochni, I'll ask Lochni. I know you know. So, Lochni, what do we always produce in an acid-base reaction? Salt and water, right? So we always produce salt and water, right? So in an acid plus base, we are always going to go to a salt plus water, right? Now, if I gave you the salt, right? If you were given the salt, could you figure out the acid and base? Andrew?
what?
If I
Yes.
gave you the salt, could you tell me the acid and base?
Yes.
Yes, you could, right? So let me give you a salt, and then you tell me the acid and base, Andrew. I'll give you Mg NO3 2. So NO3. You can't hear me for some reason. Uh, um, give me a second. Everyone else can hear me, right? I think. Okay. Whew. Alright, we're just gonna wait a little bit. Yeah, it is. No, 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 no. It's not. Close, close, close. Hmm. Is there a quick way to mute yourself on Discord?
Yeah, you press the microphone.
Yeah, but like, there's an effort.
You could
Oh,
probably make a hotkey.
okay. Can you
You
slide?
do keybinds. Yeah, you could do keybind.
You can?
Yeah.
Okay,
You push the mute.
that makes easy.
Yeah.
That makes life really easy. It's Andrew.
What?
Wait, she can hear Andrew, but she can't hear me.
It's because I'm just special. Unlucky.
I don't understand.
Feels
I
bad.
do not.
Maybe restart.
Huh?
Restart like computer or something.
Yeah, maybe restart. Tell her to restart her computer. Say Ahmed said.
Restart computer.
Oh my god, Lochni is cringy. Oh, Matt just jumps in. Hello. Okay. Tell Gimme to restart her computer, Andrew.
Restart computer.
Say Ahmed said to restart your computer.
Ahmed said to restart computer.
Okay, cool, cool. Alright. Anyways, we'll just continue and wait. We'll just see what happens then. We'll just continue. So if we're given this salt, right? We're given this salt, MgNO3 2. Now, now we know two things, right? We know two things about acids and bases. What sort of ion is always associated with the base, Andrew?
What ion?
Yeah, what ion is always associated with a base?
Isn't it?
It always
H.
tells you it's a base.
H.
No, OH minus.
OH.
Yeah, base, right? If you see this, you know it's a base. And what do we call this ion?
Hydroxide.
This is called a hydroxide. Perfect. Now, yo, my writing is getting better every lesson. Let's not lie about that. Come on.
It's still atrocious.
Okay. I was gonna ignore that. Okay, Lochni, for all of the acids, what ion is always associated with the acids? H plus, perfect. H plus is always associated with the acids, right? And we call this, what do we call this? This is quite difficult. What do we call this? I'll give you a clue. If you can't figure it out immediately, try using that Bohr's. Try drawing the structure for it.
Can I say?
Okay. Okay, let's draw the structure for hydrogen. Hydrogen is one proton in the middle, right? And how many electrons, Andrew?
2. Wait.
Hydrogen.
Wait, 0.
Huh?
1.
One electron, right? For hydrogen, there's one electron. One proton, one electron, neutral charge, right? But, now let's look at this. H plus, what does the plus sign mean, Lochni? You lose an electron, right? So you don't even have this electron. So what are you just left with?
Nothing.
A proton. So what is a H plus? It's a proton. It's just a proton. Yep. Okay? Yeah. Don't worry. I know what you're thinking of. We're going to explain that in a bit. Okay. Anyways. So now, does everybody know what Mg would look like if we split it up? Mg, what's the charge on Mg normally, Andrew?
Is it minus?
No. Remember what we said about metals? Metals always can lose electrons, never gain. So it must be a positive charge. Is it?
Oh.
Hold on. Let me see if I can help you out here. Alright, let me see if I can. Alright. Do you remember this? So this is +1. This is +2. Remember?
Oh, yeah.
So what's the charge on Mg?
Unless it's +2.
+2, right? And what's the charge on NO3? Remember we did this before? We did this last lesson. What's the charge on NO3, Lochni? Minus. Perfect. So NO3 minus, right? So you can see that we need 2 minuses and 1 2 plus to make MgNO3 2. But we can do something more, right? Now if you think about it, which of these would go with the Mg2 plus? Which one? The hydroxide or the proton? Andrew?
What are the...
Remember, we're trying to achieve a neutral charge. So which one would go with the proton? Which one would go with the 2 plus?
Isn't the oxide?
The hydroxide, right?
Hydroxide.
Yeah, so it is the hydroxide because the hydroxide has a charge of -1, right? So it would be MgOH, but how many hydroxides would we need to make the charge neutral?
2.
Perfect. So that's our base, isn't it?
So that's what I assume.
Okay? And then, Lochni, what would our acid be then? Yep. The acid is HNO3. And this goes to make this salt. And water. Now let's have a look. Let me ask you a really, really hard question right now. What is the name of this compound? What do we call this? What's the name of this base? Andrew?
Is it magnesium hydroxide?
Yeah, this is magnesium
hydroxide.
hydroxide. Now, Lochini, what do we call this acid? No. Remember, we turn the nitrate ion. Remember, this is nitrate into. Remember the ite to us and ate to ite, ik. So what do we call this? No, we call this nitric acid. Yeah, we call this nitric acid. Andrew, what do we call this salt?
Magnesium nitrate.
Perfect. Magnesium nitrate. Okay, cool. And obviously this is water. Right? We know that. That's obvious. Now, let's do another salt. So I'm going to write 2 more salts, right? And I want you guys to balance the equations if you can. Okay? So obviously this one is not balanced, but if I was to balance it, I would put a 2 here and a 2 here, right? And then it would be balanced. So I'll give you guys 3 more salts, right? So question 1, 2, and 3. And I want you guys to give me the full reaction and the names of all the compounds, okay? So the first one is LiPO3. The second one is Ba3PO42. Last one is AlSO43. Al2SO43. Okay, so can you please tell me the acid-base reactions for all 3 of these? And give me the names of all the compounds. You guys have 5 minutes. Gimme, can you hear me now? Hello, Gimme? Gimme, can you hear me now? Help. Gimme can't hear me.
Rip. Maybe she has you muted.
Maybe she did. Why can she hear you but not me?
Because she muted you.
Did I mute her? I server deafened her. And then I unserver deafened her.
Don't think that does anything.
I don't know if that would do anything.
Maybe you should get her to click on your name.
That's what I did.
Right click. Maybe her sound's just low or something.
I tried to make her change my volume. Oh, so am I on 200%? That's really weird. I can't tell if it's like a prank or something. Can you hear me now? Oh my god. Well, dude, I actually hate ginger beer.
How can you hate ginger beer?
So bad. I'm drinking it right now. It sucks.
You suck. Joking.
Alright, Andrew, do the questions.
I've done them, but I don't know what the word is.
What do you mean you can't name them?
Yeah.
What do you mean? Can you not name the salt?
Like, I know what, like, the first one, it's lithium hydroxide.
This is lithium phosphate. Oh, phosphite. Because it's PO3, right?
Okay, thanks.
Baseman jokes. Alright. Dog. You can't hear me, but you can hear Andrew? Alright, what if I left and joined? Can you hear me now? What, does it work now? What the hell? I'm so confused, dog.
Maybe we should restart cast or something.
Whoa, I'm confused, dog. Whoa, did I accidentally remove that? Is that B? Do you know if you write lol 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 lol, it looks like people drowning? Like, this is a guy. I'm so confused. Mm. I want to do no patent though. Alright, who's done with the salts?
I'm just naming them now.
Lochni, have you finished? Almost. Okay, I'll give you guys a little bit more. Yeah, you have to balance. Of course you have to balance. We might go to like 10 because of like...
I forgot how to balance.
Wait, can you hear me?
Yeah, I can hear you.
No.
Why is it just my mic that's not fucked up?
I have no idea.
Whoops. Okay. Why can you not hear me, Gimme? Oh my god. Alright. I'm gonna start on the salts now. So let's start. We'll start with lithium phosphate, whatever. So obviously we know that lithium is his Li. And can anybody tell me what's incorrect about the salt? Because I purposely left something wrong with it. What's wrong with it, Lochni? Or did you not find it? You didn't find it? So what's the charge on PO3? What's the charge, Andrew?
I don't know.
It's 3 minus.
Oh,
What's the charge on lithium?
1.
Plus 1. So how many lithiums do we need to balance the phosphate?
Right.
3. So it's Li3 PO3. Nobody got that, did they? Okay. So obviously if this is the plus, then this is with the hydroxide and this is with the H plus. So over here we get lithium hydroxide and over here we get H3PO3. So our acid-base reaction becomes LiOH plus H3PO3 goes to Li3PO3 plus 3H2O. Oh, whoops, not 3. We're going to balance this later. You can hear me very, very vaguely. She just deafened herself. Okay, so now in order to balance this equation, where do we put a 3? I mean, what do we use? Oh, okay. Andrew, where do we start to balance this equation? Do you know?
You put 3 after Li.
OH? Over here?
Li.
Or here?
I can't even see on my thing.
Here or here?
I can't even see it.
What do you mean?
Oh, the first one.
First one, 3 right here, right? Perfect. Cool. And then because we have 3 lithiums here, so we must have 3 here, right? And then in order to balance the hydrogens, if you do a quick bit of math, you'll figure out that you need to put a 3 here. Because we have 6 oxygens here and we only have 3 here. So we have 3 here and 1 here, but we need 3 more here. Because in total we have 3 O's and then we have 3 oxygens here. So we have 6 oxygens. And we only have 4 here. So then we have to make it 6 oxygens. Right? And that's how we do it. That's how we balance it. Now let's name them. So over here, this one is obviously lithium hydroxide, right? Lochni, what's the name of this acid right here? Phosphorus. Yep, cool. It is phosphorus acid. So this is phosphorus acid, right? Now, Andrew, what is this salt right here? What is this salt? What's it called?
So this lithium phosphorus acid?
No. So we know PO3 3 minus is called phosphite. Does does that give you any clue?
Oh, it's lithium phosphide.
Yes, it's lithium phosphite. Lithium phosphide. Perfect. And obviously this is just water. Yeah? Everybody get that? Is it starting to make sense?
Mm-hmm.
Okay, let's do number 2. Okay, number 2, BA3,
Where's your screen? Nothing.
my screen.
What I mean, it's my screen.
Yeah, I think my screen's fine. Is my screen fine, Lochni? Yo, what is happening to everybody today? What the hell? Okay, cool. I keep like burping in my own mouth. Can you guys hear that? That'd be awkward. Anyways, for this, oh thank God. Okay. For this, Lochni, what was the reaction you ended up with? What did you get? I'll write it in pink because you did it. If your mic works, can you use your mic? Cause like I think Hassini might have headphones.
Does it work? Does it work?
No, it does. It does not work. Oh no. Okay. All right. Maybe you should get some headphones. Eek. Okay. Oh, fine. I'll ask Andrew what he got for this then. All right, Andrew, what did you get for this?
What do you mean, like?
What was your reaction? What was the salt and what was the acid?
My base was barium hydroxide.
So no. Tell me how many hydroxides and everything.
I didn't balance it.
No. Like obviously it's barium hydroxide, but it's BaOH. How many OHs?
2.
2. Yeah, perfect. How do we know this? How can we work it out? Just by looking at the salt. How can we work out the charge on barium? Do you know?
Is it because you balance it?
Yeah, well, we know the charge on PO4 is what? Andrew?
3 minus.
3 minus, right? And we know that the charge, and if there's 2 of them, if we have 2 of them, what's our total charge?
6.
6 minus, right? So if we have 3 bariums, how many? So we have 3 times the charge on barium, which we're going to call X. X is the charge on barium. Minus 6 is equal to 0. So what's the charge on barium? 2, right? Does that make sense? Because the total charge here is 0. Right, Andrew?
Mm-hmm.
So over here we can work out that the charge of barium is 2 plus, right? Plus 2 plus. So we can see that this is BaOH 2 because hydroxide is minus 1 plus H3PO4 goes into Ba3 PO42 plus H2O. Now can everybody tell me what is the balanced equation for this? Or Lochni, can you tell me the balance for this? No, you can't. Yeah, this one's a bit tricky. Okay, so obviously we know that there is 3 baryons here, so we need 3 here. Yes? But over here we have how many oxygens? We have 3 times 2, 6 here, plus 4. That's 10, right? We have 10 oxygens. But over here we have 8 plus 1. That's 9 oxygens, right? However, if I made this 2, if I put a 2 here, then we would have 6 plus 8 oxygens, and we would have 14 oxygens. So in order to make this 14, this has to be 6, doesn't it? So it's 8 plus 6, which makes it 14. And now, if you check the hydrogens are also balanced. So this is what our balanced equation looks like. Okay? That's our balanced equation. Now, the last salt, 3, is Al2SO4 3. Yeah? Lochni, can you tell me what you got for this salt? And then I'll quickly ask Andrew to name the last one and Lochni to name this I'm not gonna name them yet, just wait. Perfect. So whoops, let me do it in pink because Lochni's obsessed with that. So we have AlOH3 plus H2SO4 goes into Al2SO4 3 plus H2O. Lochni, did you get the balance for this? No, it's 2316. Okay. Yeah. Anyways, let's quickly figure out what this is. So, Andrew, what do we call this right here?
Barium hydroxide.
Perfect. What do we call this, Andrew? Phosphoric
Phosphoric
acid. Barium phosphate. And water. Yes? Okay, over here we have aluminium hydroxide. We have sulfuric acid. We have aluminium sulfate and water. Yep. Now, let's move on to our... Now, since we've learned all of this, let's have a quick revision on all of our common ions. Okay, common ions. I'm going to write down the ions and then you're going to tell me the names of them, okay?
I'm lacking.
But you're lagging.
Yeah.
Well, how are you lagging?
Oh, because your screen was had nothing, and then a few seconds that you written like all that.
Really?
Yeah.
Wow. What is happening with everybody's internet today? Okay. So, can you see that, Andrew? Is this fine right now? Hello?
What?
Can you hear? Can you see the
Yeah.
screen? Is it fine right now?
Yeah.
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 All right. Cool. All right. Does any we didn't go through this one, NH4 plus. This is ammonium. Not to be confused. Do not confuse this with NH3. This is ammonia. Okay, ammonium and ammonia are not the same. Okay, NH3 and NH4 not the same. Okay, Andrew, what's OH minus?
Hydroxide.
Perfect.
Wait, which one?
Yeah, OH minus is hydroxide.
Oh.
All right, Lochini, what's NO2 minus? Nope. Nitrite. Try again. What's NO3 minus? Yeah, nitrate. What's CO32 minus? Does anybody know this?
Carbonate.
Yeah, perfect. It's carbonate. Carbonate. What's SO33 minus, Lochini? Sulfite. Yep. I spelled it with a PH, but it doesn't really matter. And Andrew, SO4 minus, SO42 minus.
Is it sulfate?
Yep. Wow, I can't even spell. Okay. PO33 minus. Do you know what that is? In Lochni? Phosphite. Perfect. Andrew, what's the next one?
Phosphate.
Perfect. Okay, Lochni, what's CLO minus? Nope. Hypochlorite. Chlorate. Perchlorate. Okay? Now special ions. Let's have a look at these ones. So these ones you guys do not know, but you must know. Okay? You must remember these. Must.
Can you go back up, please?
Yes, sure. There you go.
Thank you.
Okay, cool. Is that fine, Andrew?
Yep.
Okay, cool. So these are special ions. You must remember these ions, okay? So this one is called permanganate. Permanganate. I actually can't spell it for some reason. Permanganate. It's one of those. Call it permanganate. This one is called acetate. This one is chromate, and this one is dichromate. Okay? So these ones you must know. Super important, okay? Super important. You must know them all. Okay? Cool. So now, once you guys know your special ions, you must remember the names of all these special ions. We can move on to some other ones, right? Let's have a look at some special anions, right? So anions, hold on, anions, you have to add an "ide," okay? So for all the ones that are singular element ones, so singular element, So what I mean by that is O2 minus, S2 minus, N3 minus. Okay? So something like these are only using one element, right? So you have to add an I to them, right? Something like, something like F minus, Cl minus, Br minus, I minus. Yes? Does that make sense? So for all singular elements that have a negative charge, you have to add an I to them. Okay? So, Andrew, what's this normally called?
Oxygen.
Yeah, so what would it be called?
Oxide.
Oxide. And what would this one be called?
Sulfide.
Perfect. Sulfide. Alright. What's N3 minus?
Nitride.
Yep. Nitride, yeah. Okay. What's F minus then, Lochni? Fluoride. What's Cl minus then, Lochni? Chloride, perfect. Vice versa. I mean, etc. So what are these? What's this group called, Andrew? What's this group called?
What do you mean?
This is called the halogens.
Halogen.
Yeah. Cool.
Yeah.
Great. Okay. So let's do some simple reactions and let's try to name them. Ba2 plus I minus makes what? And balance the reaction. Al3 plus Cl minus makes what? Li plus O2 minus makes what? Na plus N3 minus makes what? I'll quickly do the first one for you guys. Okay? So over here we have a +2 charge. Over here we have a -1 charge. So in order for this to become balanced, we need two of these, right? I mean, not +2. We need two of these. So times 2. We need two of these, right? So it's BaI2. And since we have two iodines over here, we need to have two here. Perfect. Now, can you guys do the rest? You guys have 2 minutes. Okay. Okay, cool. So, bear with me. I'm chewing on some food. Over here, we have AlCl3, and this is called aluminium chloride. Over here, we have Li2O, lithium oxide, Na33N. This is sodium nitride, sorry. Can you please say I'm a god if you got all of them? No. I meant I'm a god, not I'm a god. Okay. And obviously the balance, whoever's forgetting the balance, there's 3 chlorines here, 2 lithiums here, 3 here. Perfect. Who forgot balancing?
Nope.
Lochni, did you forget balancing? Wow, well done. Well done. Shocking. Okay. Cool. Now I'm going to move on to an exam question. Why does, whoops, let me rewrite that. Why does oxygen have a charge of -2 most commonly? Use Bohr's model to explain. Okay. Does everybody know what Bohr's model is?
Mm-hmm.
Bohr's model is those, Bohr's model is like, remember that? That thing? And then you like drew the electrons?
You drew an eye. Yeah.
Yeah. That actually looked like an eye. Yeah, that's Bohr's model. Okay. I'll give you guys a minute to try this because this is quite an important question. Actually, no, I won't give you a minute. I'll tell you what it is. Okay. So, can everybody draw oxygen for me? Okay, can everybody draw oxygen for me in Bohr's model, right? So that we would have perfect. That's oxygen, right? So let me like quickly like yeah, that's oxygen. Now, in the first shell, remember oxygen is element number 8. So therefore 8 protons, right? And so if we know it's 8 protons, we also know it's we also know it's 8 electrons. Now, since we know it's 8 electrons, 1, 2, oh god, let me just, sorry about that. So it's 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, can everybody draw me oxygen 2 minus? So what does the 2 minus mean, Andrew?
We have 2 more electrons.
We gained 2 electrons, right? So that means that in my oxygen, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, because 8 plus 2 is 10 electrons, right? So what do we see when we have 10 electrons, guys?
It's not stable.
No, it is stable, right? Because it's a full shell. We see a full shell, right? And because we see a full shell, it's super stable. That's why we see oxygen having a charge of -2 all the time, because when it's at a -2, we have a full shell. Does that make sense?
Mm-hmm.
Lochni, does that make sense? Cool, cool, cool. Now, last little part of naming that we're going to do is everybody remembers in the periodic table, right? Our periodic table, let me insert it actually. Oh, what happened? Not a printout, a file. Sorry. Let me insert. Huh? Alright, there you go. Thank you for not being annoying. Okay. So in our periodic table, we see that we have our S block. We have our, over here, ignore me for not being able to draw perfect squares, P block. And over here we have our D block. Right? Now, in our D block, we have something that happens, right? Our D block is called the transition metals. And the reason that they're called transition is because they transition between oxidation states. So let me quickly write that somewhere else. Transition between different oxidation states. That's why they're called transition metals. And what is an oxidation state? The simplest way to understand what an oxidation state is the charge at the top, okay? So this is a -1 oxidation state. This is a -2 oxidation state. This is a -3 oxidation state. Does that make sense? So, for example, we have iron, right? But we have a couple different types of iron. We have FeO. We have Fe2O3. We have manganese. We have MnO2. We have MnO3. We have Mn2O7. Now, Lochni, what's the charge? Now, we know that the charge on oxygen is -2, right? Because that's where it's the most stable. Just like nitrogen is the most stable at -3, or aluminium is the most stable at +3. So we know that oxygen's charge is -2. What would be the charge on iron then? For it to be FeO? +2, right? So over here, we have an iron +2. But what's the charge on iron in the second one, Lochni? So in the second one, what's the charge on iron? +3. Right? So you can see that these are different. Hold on, give me a second. These are different oxidation states. These are different oxidation states, right? So, over here, Andrew, what's the charge on manganese in the first one?
+2.
+2. What's the charge on it on the second one?
Is it -3?
No, it's +4. What's the charge on it in the third one?
+6.
+6. What's the charge on it on the second one?
+14.
+7. Because we have two of them,
Oh,
right? So we have to half the charge. It's +14 divided by 2 because there's two of them, right?
I didn't see the 2.
Oh yeah, sorry. Bad writing. So it's plus 7. So you can see that they're different, right? So the way that we denote this, or the way that we like to write it because we're annoying, is we say this is iron 2 because the charge is plus 2. Iron 2 oxide. This is iron 3 oxide. And notice, if you have a transition metal and you're asked to name it in Chemistry 1, you will lose all your marks if you do not give the variable oxidation state. Does that make sense? This right here is the variable oxidation state, if you were wondering. Yep, does that make sense? Cool. So over here, Andrew, what would we call this one right here? The third one.
Magnesium 2.
It's not. So notice. It's not Mg. It's not equal to Mn. Mn is over here. Manganese is different to magnesium.
Manganese, yeah.
Right?
Yeah.
So this is manganese.
2.
Manganese 2 oxide. What's this one?
Manganese 4.
Manganese 4. Who knows how to write the Roman numerals?
Kind of.
Oxide. What's this one?
Isn't that VI?
Yeah. Manganese 6 oxide. And this one is manganese 7 oxide. I'll quickly write down the Roman numerals from 1 to 10 because I feel like everybody should know them, but I feel like nobody actually does know them. So I'll quickly write down them. So 1, 2, 3, 4, 5, 6, 7. Okay, so 1 is 1, 2 is 2, 3 is 3, 4 is this, 5 is this, 6 is this, 7 is this, 8 is this, 9 is this, 10 is this. Okay? So just so you guys quickly know, these are all the variable oxidation states of those are all the Roman numerals from 1 to 10. So if you guys don't know them, you guys should start memorizing them because you'll need your variable oxidation states. Cool. So now we're done with naming, which means I'm going to give you guys a butt ton of naming homework. Right? Obviously. So let's move back to our let's continue to types of reactions. Right? Types of reactions. Now, there are a lot of different types of reactions, right? I'll start with the simplest one, okay? So the first type of reaction is called a synthesis reaction. A synthesis reaction, right? So in this, an element or compound combine to form a single compound. Now it'll always form a compound because we need more than one element, and two different elements combined make a different compound, right? It makes a compound, not an element. So a general equation for this would just be like A plus, let me write it in blue again. It's like A plus B plus C plus however much you want goes to one compound D, right? That's a synthesis reaction. So let me give you an example. An example would be, oh, you can hear me now. Oh, wow, okay. Well, you can pay attention because we just started a new topic, so that's good. You can, we just started types of reactions, so you can, yeah, it will make sense. So over here, we have 2 hydrogen plus oxygen goes to 2 water, right? That's a synthesis reaction, as you can see. And what method does this happen? How do we make this? Does anybody know how to split up water? We went through this in the tube.
Electricity.
Electrolysis, yeah. Good. Wow. Shocking. Okay. 2. Second reaction would be decomposition. Decomposition reaction. So it's a single compound breaks into two or more compounds or elements. Now let's have a look. So the general equation for this is A goes to B plus C plus blah blah blah. Yeah? So let's just quickly give me, can anybody give me an example? Does anybody know an example? Okay, probably not. I'll give you guys one. Goes to H2O plus CO2. So this reaction is a very unstable reaction. This compound is super unstable. This compound is called carbonic acid, right? This is the reason that our water is always pH slightly less than 7. So our water is always slightly acidic because water plus carbon dioxide makes that. So when we take from the carbon dioxide from the air added to water from your glass of water, will make carbonic acid. And when you make carbonic acid, our water is always slightly acidic. Okay? Does that make sense? So that's why. And in order to like convert this carbonic acid back into water and carbonate ion, we have to just shake the bottle. So if we shake a bottle with water in it, it will most likely release most of the carbon dioxide from it. Okay, because remember carbon dioxide, this is a liquid. Remember, this is a liquid, but carbon dioxide is a gas. So that's why the carbon dioxide will just fly away, right? And it'll bubble. That's why you always get little bubbles when you shake up water. Otherwise, you wouldn't actually get bubbles. Funny story, huh? The third reaction that we were gonna should learn. Fancy color. I love this nice looking color. It's a single displacement reactions. Wow, does this not trip out your eyes? Honestly, wow. Okay, so it is a more active element replaces a less active So a more active element replaces a less active element in a compound, right? So basically what we would be saying is the general equation for that is A plus BC goes to, notice that this goes to AC plus B. Okay, so an example of this is Fe plus CuSO4 goes to FeSO4 plus Cu. This is over here Chem 7. You learn this reaction in Chem 7. It's actually very dangerous. And in this reaction you produce nitrogen dioxide or NO2 gas, and that's super dangerous, like, because you inhale it and it could kill you. And when I inhaled it, like my nose was like irritating for like 2 hours. It's like really, really bad for you. But you do it in Chem 7. Okay? So it's a really, really interesting reaction. You'll see it makes really nice colors. It's really cool. But like you're going to be low-key terrified because even the teacher's like, "Oh yeah, this reaction is like really dangerous, but like you can do it anyways." So yeah. Okay. Okay, so last one. Next one, keep going. I'll probably use like a less stable color. Now we did single displacement, now we're gonna do double displacement. So for double displacement, two compounds react to form two or more new compounds. So let me give a little note for this. So guys, please note that the formation So the formation of water or a gas or a precipitate usually drives these reactions. What the hell did I write there? That is not a word. Usually drives these reactions. So what that means is normally these reactions occur because you want to form a precipitate or you want to make a gas or you want to make water. Right? So a general equation for this would be AB plus CD goes to AD plus CB. Now, why is it not the other way around? Why can't it be AC, Andrew?
Because they're both like the start thing.
Yeah, so if they're both the start, they're both positive, right? So A is positive and C is positive. A positive can't be with a positive, but we know D is negative and B is also negative. So we know that this negative can go with this positive and this negative can go with that positive. So we make AD and CB. Does that make sense? Cool. It's going to take that as a yes. All right. Last in reactions.
Combustion,
Wow, how did you know?
I guess.
Combustion reaction. We actually have one more type of reaction after this, right? So, combustion reaction. So, this is a substance reacts with oxygen in the air Okay, so a substance reacts with oxygen in the air and burns to form either carbon dioxide and water or carbon monoxide and water, right? And if you form carbon dioxide and water, you've had a complete reaction. And if you form carbon monoxide and water, you have an incomplete reaction, right? And notice that that's the only products that they can possibly make, okay? And notice this substance is always a hydrocarbon. Does anybody know what a hydrocarbon is? I'll take that as a no. So a hydrocarbon is in the form CXHYOZ. That's a hydrocarbon, okay? Anything in the form CXHYOZ, that's a hydrocarbon. So we would say that CXHYOZ plus oxygen gas O2. This O2 means burning. If you burn something, you're putting O2. This makes CO2 plus H2O. That's the general equation for that, okay? And then I just want to quickly go up for the sixth type of reaction. It's a very special case. So 6 is a very special case of double displacement, and that is an acid-base neutralization. So why I'm saying this is even though acid-base neutralization is a double displacement reaction, if you write double displacement on the test, you are actually going to lose marks for saying it's a double displacement reaction. Okay? So don't say it's a double displacement reaction. It's a acid-base reaction. So make sure every time you see salt plus water, you know that you've had an acid-base neutralization, right? So I'm gonna write up a couple reactions, and then you guys are gonna balance them for me, and you guys are gonna tell me what type of reactions they are. Is that cool?
You can go up a little bit.
Sure, sure.
Yeah.
Cool.
Okay.
Okay, cool. Okay, I'll quickly so I want you to balance them and then tell me the type of reaction. Okay? So Cu plus O2 makes CuO. PbO plus H2 makes Pb plus H2O. PbCO3 plus 2HCl makes PbCl2 plus CO2 plus H2O. This one is going to be the trickiest one, by the way. ZnCO3 goes into ZnO plus CO2. CH4 plus O2 goes into CO2 plus H2O. CH4 plus O2 goes into CO plus H2O. Okay? So can you guys please balance and tell me the type of reaction this is? You guys have 5 minutes. Gimme, are you done? Okay, cool. So, let's do this then, huh? Okay. So, over here, we have, let's balance this. So, obviously, if we have 2 oxygens, we have to put a 2 here. So, if we have 2 oxygens here, we have to put a 2 here. And if we have 2 coppers, that means we put a 2 here. Okay, so that's that balanced. This one is already balanced, so we don't need to. But this right here is a synthesis reaction, and this one right here is a single displacement reaction. This one right here is an acid-base reaction. Who got that one? Can you please type 7,000 in the chat if you got that? Okay, so only Lochni got that?
I forgot to write it.
If you can see over here, this is a salt, so that's why. Okay?
Oh, I forgot to write it.
Yeah. And this one is also kind of balanced considering the fact that I wrote the 2 there for you. Over here, this one is obviously a decomposition. And Andrew, how would we balance this one? Do you have any idea?
Nope.
Okay, so you don't know. Lochni, what about you? Do you know how to balance this one? Perfect. It is balanced. There's no need to balance it. Okay, second one, this last one. Give me, what's this reaction? What's this type of reaction called? Hello? Gimme? Combustion. Perfect. This is combustion. But what type of combustion? There's 2 types. Is it combustion? Which one? Which type of combustion is it? Because remember there's 2 types. If you... Perfect. It's complete combustion. Perfect. And this one is obviously incomplete. Okay? And let's balance these. Over here, there's a 2, and there's a 2 here. There's a half, and there's a 2 here. Okay? That's the balance for them. Cool. Now, before I move on, I'm going to, we're going to talk about one more type of reactions, which is reactions with acids. So, the first type of reaction with the acids is acids and bases, right? So, this is also called a neutralization reaction. I don't know how to spell neutralization. Which is a double displacement, right? It's a double displacement reaction. It's a double displacement reaction, right? So for all of the 2 years, right? Let's just quickly before I move on to like the types of reactions. For all of the 2 years that we're gonna study the chemistry in Narabanda, the how you solve an equation is for the 2 years. You take your chem equation for all chem equations. You find the products, right? Because you don't know them normally. Then second, you balance. And the third thing is you put the states if you can, okay? Especially in Chem 1, don't forget the states, okay? Don't forget the states. So, we will cover states on another day. So for now, we're going to leave the states. But we will cover them later. Anyways, so for now, H2SO4 plus NaOH. Andrew, can you please tell me the product of this reaction?
You get H2OH plus NaSO4.
NaSO4, are you sure?
Yeah. Maybe.
Can I move up a little? Sure. Is that all you needed? So for this one, remember the charge on
Oh,
SO4
no.
is SO4 2 minus. So this is Na2SO4 plus H2O. This is our salt, and this is our base. And notice that the charge on sodium is just the +1. That's why, right? Now, let's have a look. So, let's balance this really quickly. How would we balance it? Gimme, how would we balance this one? If your microphone is working, you can just say it. Yeah, I'm using your phone, so you gotta find it. What? Okay. Okay. Well, I'll just quickly tell you because we can't. We don't have enough time. But if we have a Na2 here, then we need 2 here, right? And if we have a 2 there, we can see on this side we have 2 hydrogens and 2 hydrogens. In total, we have 4 hydrogens. It's not a problem, gimme. And then over here we only have 2 hydrogens, so we need 2 here, and then it's balanced. Okay? Now before we move on, I need to discuss the types of acids and bases. So types of acids and bases. Okay, now what did we figure out about a H plus? What's it called? Lochny, what's a H plus called? Proton. Perfect. It's called a proton. So what that means is that if something is like, for example, HNO3, sorry, not HNO3, let me make this more general. If we have HA, where A is the acid ion, HA is a monoprotic acid. Does that make sense? Because there's one hydrogen. Protic means proton, remember? Right? And if it's H2A, what type of acid would this be, Andrew?
Dual protic.
Close. It's diprotic. This is diprotic acid. And H3A, Lochny, what type of acid would this be? Triprotic. Perfect. And so forth, right? Quadprotic and whatever, blah, 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 blah. So, I'll quickly go through this. It's a di, tri, tetra, penta, hexa. So everybody should know that, right? That just goes increasing 2, 3, 4, 5, 6, and so forth. Can anybody tell me what 7 would be? Andrew? Or Lochny? Or anybody? Or Gimme?
You can search it up.
No, you can't search it up. I know what 7 is. I'm asking you. Yeah. Close. Heat. Did you get corrected? Close. It's septa. Right, that's 7. And octa is 8. Okay? So those are namings, right? But we're never gonna get an 8 hydrogen acid. That's just never gonna happen. So only triprotic is the most we go up to, at least in Narrabanda College. And let's talk about the bases, right? So something that is BOH, that's called a monobasic, right? Or I'll just say like NaOH, something like that is monobasic. What about BOH2? What would that be called, Andrew?
Um, dipro.
Dibasic,
Dibasic.
right? Because we're talking about bases now. Remember, this is bases. So we have the hydroxide, right? And BOH3, Lochni, what would we call this? Tribasic, perfect. So this is a tribasic, monobasic base, tribasic, dibasic base, tribasic base, right? So you can balance these acid-base reactions by knowing the type of reaction. So over here, we have a diprotic acid. We have a monobasic base, right? And so if it's a diacid and a mono base, we always have a ratio, and we get salt and water. We have a ratio of 1 to 2 goes to 1 to 2. Okay? That's always the formula for a diprotic acid and monobasic base goes to salt and water. That's always the balance for it. Okay? And this happens for a lot of them, and I'll give you guys a summary sheet for all of them so you guys can quickly go through them and memorize them if you want to, or you guys can figure them out if you want. Anyways, so now let's quickly move on to states, right? States. Because we haven't talked about states. States. So there are a lot of different types of states. Andrew, can you tell me the 4 possible types of states?
Isn't it solid, liquid, gas, and aqueous?
Yeah. So we have aqueous, which is AQ. We have solid, which is S. We have liquid, which is liquid. We have gas, which is G, right? And something that is aqueous is normally a compound element. So any element in a compound is always aqueous. And any element that is just a solid is obvious, right? It must be a metal or something like that. Like magnesium, solid. That's just magnesium, right? And something that's a liquid is water, bromine, mercury, right? These are liquids. Gases, hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, and all noble gases, because they're called noble, right? Gases, so they're obviously gases. Now, over here, let's quickly put the states on this. So, what would this one be, Andrew? If you were to guess,
Aqueous.
this would be aqueous, perfect. What would this be, Andrew?
Is it main? Aqueous.
Yep. What about this one?
Aqueous.
Perfect. What's this one?
And liquid.
Perfect. There you go. That's how you do it. It's that simple, okay? You must put your states, I'll quickly write that. You must put states, whoa, that's a really bad T. You must put states, I'm actually disabled. You must put states in every single chemical reaction you do in Chem 1. The only time you can forget states is Chem 5 and 7. Those are the only 2 chemistries you can forget states. Chem 5 and 7 is no states. But as far as you're concerned, you only talk about states for at least a year and 1 term. Okay? So those are the only 2 chemistries you don't talk about states. Because by then they're like, oh well, you know everything, right? So like, why would we do that? Okay. Now let's move on to the second type of acid reaction, which is an acid metal reaction, right? So an acid metal reaction. And this is also called a single displacement reaction. It's also a single displacement. It's also single displacement. So over here we have an acid, and an acid is always what state, Andrew?
And aqueous.
Aqueous, because it's a compound, right? And metal would be in what state, Lochni? Solid, perfect. And this would go into a salt plus hydrogen gas. Now, what would the state of the salt be? Gimme?
Solid, right?
Whoa, that thing's happening with your thing too. That's weird, huh? So
Let's go.
since salt is a compound, right? It's a compound. It's not a single metal. It's a compound, so it's aqueous. Remember we said that all compounds we just assume aqueous because that's our best guess. And then what would hydrogen gas be, Gimme? Perfect gas. Because I literally said hydrogen gas. But yes, perfect. It is gas. Perfect. So over here, I'll give you an example. So HCl is an acid. Everybody can see that. Plus 2Na. We get sodium chloride plus hydrogen gas, right? And I'll quickly balance it for you guys. Oh, I'll probably use something else to balance, some other color. Let me use like red, because red always looks nice when you balance it like that. Okay, anyways. So over here, we have aqueous, solid, because remember, sodium metal is solid. Aqueous gas. Perfect. Remember. Okay. And the last type of reaction for acid types of reaction is also an acid-base reaction, but it's a special case. It's called an acid. I'll just use green. It's called an acid carbonate reaction. So everybody knows the carbonate ion is CO3 2-. Remember that? So what happens is we get an acid plus a carbonate, or this thing, a hydrogen carbonate, right? And then we get a salt plus carbon dioxide plus water, right? So I'll give you an example. HCl plus Na2CO3 goes into NaCl plus CO2 plus H2O. But I'll quickly balance this for you, and I'll quickly tell you something else about this very fancy reaction. It's actually a very, very difficult sort of thing to understand. We actually understand it way in Chem 5, but what actually happens is before it becomes to this, right? This is the last step, okay? This is last step. There's a step before this. So we're going to call this step number 2. Step number 1 is actually goes to NaCl plus H2CO3. But what did we say? What did we say was the problem with carbonic acid, Andrew?
I can't remember.
It's super unstable, right?
Yeah.
And carbonic acid splits into CO2 so carbonic acid becomes carbon dioxide and dihydrogen monoxide, right? Does that make sense? Because remember we talked about it like somewhere here. It was somewhere here, I promise you. Okay? We definitely talked about it. So, hydrogen carbonate is super unstable, or carbonic acid is super unstable, and we get carbon dioxide and water. So that actually is how we go from step 1 to step 2, right? So that's where we get the carbon dioxide and water from, right? So that's this, if that makes sense. So that is why. Does that make sense, Andrew?
Mm-hmm.
Okay, so we have 20 minutes today left, okay? So what we're going to do is I'm going to put up a bunch of reactions, okay? and you guys are going to find the products. And then you're going to balance them. I don't need you to tell me the type of reactions. That's for your homework. Okay? So, oh my god. Oh, fine. We'll play Hangman after. Okay?
Well, I ended your career though.
Nah, you didn't, dog. It doesn't count. You have to beat me. I don't have to beat you.
I did beat you.
Alright. Alright, I'll write up some reactions quickly.
And it wasn't Chinese as well.
That's true, that's true.
Chow Ni Ma.
Shouldn't say that.
I'm Asian. It's okay.
Is it okay? I can say it too. Um.
Hooray.
Sure, sure. I'll zoom out at the end. So just let me finish this quickly, and then. Okay. Here we go. Is that better, Gimme? Cool. So you guys have 5 minutes starting now. Finish the entire thing. Balance the equations.
What the heck?
So, who's finished? Well, the faster you finish, right? The more time you have for Hangman. It's a scene, isn't it? Yeah, it's a scene. Okay, so one person is done. Gimme, are you done? Okay, keep going. That was a teeny. Stop. Just type HH when you're finished. I don't think Hassini is stable, so ignore that, guys. So who's done? Just Lochni still? Remember, you just have to type when you're done. Type HH when you're done. Okay, guys, we're just gonna continue because I don't think anybody else can finish in time. So we'll just quickly finish this up real quick. Okay, so obviously, sorry, my very annoying. Yep. So, please stop. So obviously over here, we can see that this is calcium plus HClO. This is a acid. Oh, let me quickly like zoom in. This is an acid, right? So this is a metal. So an acid plus metal is a. Remember, we just get an acid salt. So this is CaClO 2 plus H2 gas. Remember, we don't need to balance the reaction yet because that's for homework. This one is AlNO3 AlNO3. Sorry, what's happening? Yeah, so this is AlNO3 plus H2 gas. This one is Li2S plus H2 gas. This one is Ba3PO42 plus H2 gas. Remember states and everything. This one is K2S plus H2O. This one is HNO3. Oh, sorry, not HNO3. Whoops. This one. This one is AlNO3 plus H2O. Okay. Over here, this one is MgSO4 plus H2O plus CO2. This one is LiCO3 plus H2. Oh, sorry, LiNO3. Sorry. Plus H2O plus CO2. This one right here is BaSO4 plus H2O plus CO2. This one is K3PO4. K3PO4 plus H2O plus CO2. Can you please type HH if you got this right? All of them? So nobody got all of them right. Can you please type HH if you made a mistake? Ah. Ah, okay, so a lot of people made a mistake. I see. Okay, so for homework is states and balance. States and balance. Okay, so can you please get the states and balance this for homework, and I'll send a bunch of more homework sheets. So be on a lookout in this chemistry year 11 chat. So year 11 chem, please look out for homework. It will be given to you in 1 to 2 days. It will be on the chat in 1 to 2 days, and you have until Tuesday next week to finish. Okay? So, that's it for today. Homework will be in the chat. That's it for today. And, oh yeah, we have to play Hangman, so quickly. Okay. First of all, before we play Hangman for some pizza, who wants to verse me for some pizza in some tic-tac-toe? Because I'm actually unbeatable at tic-tac-toe. So can you type HH to the chat if you want to verse me in tic-tac-toe? Alright, sure. So, Lochner, you're gonna have to kind of, like, have a mic. Because, like, you're gonna have to tell me which square. I'll go first, because I'm ladies first. Alright, where are you going then? Yeah, alright, just say the square and the number. So I'll say A, B, C, 1, 2, 3. So if you wanted, like, B2, that's this one. Or A1, that's this one. Or A3. So you just type in your square number. B2, okay. I'll go next. I'll go here. What about you? A1. Here? Cool. I'll go here. Where are you going next? Lochni? B3. Okay, I'll go here. I win. GG. Okay. that was too easy. Alright, now we'll play some Hangman, because you guys absolutely suck at that. Oh, OGD. Dog. Alright. Yeah, okay, I got it. Let me quickly think of a word. Alright. Okay. Who's guessing?
I can use a Hangman cheater now.
Try it then. Why did you say so? My bad. Why did I say so? My bad. What? Can I guess? Yeah. You guys can guess. Yeah. GG. Alright, yeah, sure, G. D.
I.
Okay, A.
Well, let's go.
O. Okay, that's fine. P. Come on, Andrew.
M.
M. Yep. T. Yep.
W.
W. Right. Yep. Y. M. M's already been guessed.
H.
H. I. O has been guessed.
C. C.
Okay. C.
Really?
Okay, all good. Keep going. K. Okay.
L.
L. Hangman!
What was
You guys suck. Jazza. You guys, you told me to
That's
use
not
jazz. I
word.
took your advice.
That's not a word.
It is a word.
That's not.
Yeah, hold on. Wait. If I type in drawing with Jazza, you see? Jazza, Australian YouTuber.
Hacks.
See? Why does Andrew sound so much mature than Matt? Alright. Alright, well, one more round. Okay? One more round. To see who can defeat the king of Hangman. Which
I
is
beat you.
which is me. Okay.
Sit down.
So we got this GG. Okay. There you go. Let's go. I'll do an actual word. Here you go. I'll do an actual word. Let's go. No, actually, there you go. Alright, hurry up. Who's guessing? F-U-C-K? Are those guesses? Oh, is that a guess? Alright, who's guessing? Come on, guess.
I.
A.
Yeah.
Okay. Y. B.
O.
Wait, are we guessing a B or an O?
O.
Okay, okay. B, B. E. Come on, mate.
I.
I. L.
That's no word.
It is literally next to me is a blue stick spelled BLU. And hence it's a word.
I love you won.
Yeah, but you won, but second time around, so it's best of 3, which means last match wins. Oh wait, last match.
Maybe I choose a word.
Nah, you can't choose the word. 0 is equal to 1, 1 is equal to... Nah, don't give me that. Alright. Alright. So, last word. Oh, you have to make me make it hard, don't you? Oh, let me think. I need to like. I'm not researching. I swear. I'm just thinking.
No, it's a line and a half.
All right, let me think. Hmm. Yeah, sure. All right, just leave her. Okay, let's go. What is it? Come on, mate. Are we guessing a word? Are we guessing a word? All right, guess a word. Letter, sorry. A,
A.
A, P, T.
You're just writing random words.
H, X.
A.
No. X is there. Oops. What else? B,
No, A.
E. GG, you know what's up. Oh, wait, no, that's not it. Sorry. That's it. K, N. Come on, mate. Last round. It's 1-on-1, so we gotta make it 2-1, and then I win the game. You. Absolute garbage.